Hello, everyone, and welcome to our webinar on navigating Kubernetes observability. I'm your host, Arun Kannan, and I am a senior product manager at ManageEngine's FSO division. Before we get started, could you please give me a reaction if you can hear my audio and you can see our video? In order to get started, let me quickly introduce you to our special guest today. It is Viktor, and he hosts and owns a YouTube channel called DevOps Toolkit. Apart from that, he is also a lead rapscallion at Upbound, a member of the CNCF ambassador, Google developer as experts, CDF ambassadors, and GitHub star groups, and also a published author. Besides his YouTube channel, Viktor is also a co-host of the podcast DevOps Paradox. So welcome, Viktor. We are delighted to have you today.
Thank you for having me.
All right. So this session would be discussing on navigating Kubernetes observability. But we will first quickly walk through an introduction on Kubernetes. So even though a lot of the people who have joined today will be Kubernetes administrators, maybe a quick walkthrough as to what Kubernetes is, what it does, how it is actually helping organizations scale their applications. So beyond scalability and automation, what other benefits are there in using Kubernetes?
Yeah, we'll make a small correction. When you said applications, that means that Kubernetes is limited to applications, which I don't think it is. So one way to describe Kubernetes would be to say that it is a base platform on top of which build some final platform, whatever that is, and that will differ from one organization to another. And the main advantage of Kubernetes really, actually, there are multiple advantages. One of them being is that it has extensible API, meaning that all the communication with Kubernetes goes through API and it is extensible, meaning that we can extend it ourselves. And we do that either by installing third-party applications or by building our own extensions of that API. And we extend the API by applying essentially two things. That's CRD, or custom resource definition, which tells Kubernetes, okay, what is the API schema of something that you want me to be able to process? And Kubernetes itself is dumb. It does not know really what to do with anything. It only knows how to accept a request based or a resource defined on an existing schema, and how to create an event that says, hey, somebody just created or updated or deleted this thing, whatever it is. I don't know what to do with it, right? And the second part are controllers. Those are basically processes, let's say mini applications in the Kubernetes cluster that are listening to those events. And so there is one controller or zero controllers or many controllers that are subscribed to a certain event, like, hey, whenever somebody creates a deployment, I want to know about it, and then I will do something, right? So those are the two primary components of Kubernetes. It's the API that can be extended and controllers that do something for us. Now, the question is, what do they do for us? And for majority of people, the first association, hey, they manage containers, right? That's what Kubernetes does, which is absolutely not true. Even if you don't extend Kubernetes in any form of way, which everybody extends it, but let's say that you don't. Your Kubernetes cluster is going to manage storage, right? Whenever you create a storage class, sorry, not storage class, but storage claim, you are basically interacting with something outside your cluster to get the storage and attach it to one of the nodes. Whenever you create or install Ingress controller, what does it communicates with some API somewhere else outside Kubernetes, and it creates a load balancer for you, right? So even from the start, if you don't change anything related to Kubernetes, it is, or out of the box in a way, it is managing containers. It's true that those are your applications or third-party applications, but it is managing external infrastructure as well, like storage that I mentioned before, and many, many other things. And then that's all if you limit ourselves to core Kubernetes, which nobody uses it out of the box, right? It's too limiting. It doesn't do much. And then once you install some third-party applications or your own, then you're extending the capabilities of Kubernetes. Like you install Argo CD, and all of a sudden, your Kubernetes cluster will monitor some Git repositories and synchronize desired state stored in there, right? You install Cert Manager, and Cert Manager will be configured to talk with some external service to get your certificates, and so on and so forth, right? So what Kubernetes is, nobody can really, in a final form, nobody can really define, because it all depends on what you install in it and how you configure it.
Yeah, I understand. Yeah, that gives us a clear picture on what Kubernetes can do, and that it is not just a simple container management solution or a container management platform. It is much more than that, and it has a lot of different use cases that it can be used for in order to improve productivity. But as Kubernetes matures, have you seen teams, or have you come across teams who over-engineer by leaning too heavily on its ecosystem, and not even handling very simple workloads, and just depending completely on Kubernetes? Have you seen such cases, and has that been beneficial for them, or has that troubled them?
I don't think that question should be related to Kubernetes, right? If you change the question and ask me, have I seen the teams that over-engineer whatever they're doing, be it mainframe or Kubernetes or anything else, the answer is always yes. Of course, engineers like to over-engineer. Engineers are like kids. We like to play with stuff, right? And then we like to try new stuff. We over-engineer stuff. Of course we do, right? Now, whether that's a good thing or no, independently whether it's Kubernetes, very often it's not. But it has certain benefits as well, because if you play with stuff, then you're learning things, and then even though you might not be using it today, you might find out tomorrow when you face a problem. Oh, now I remember, that thing that I was playing around with, that's something that can help me, right? So it's a double-edged sword. But yeah, going back to your question, do people over-engineer Kubernetes? Of course, they over-engineer everything, right? That's what we do.
That's true. So despite the basic Kubernetes having a lot of capabilities, the market is also flooded with a lot of other solutions. Like, for example, Red Hat has spinned off its own version called as OpenShift. VMware has Tanzu. So there are a lot of other Kubernetes, I wouldn't say flavors, but a lot of solution built over Kubernetes for orchestration, automation, and all that. So why? I mean, I understand some of the use cases as to why that is done, but do you see some benefits? Like, for example, has someone come to you and said, I prefer using OpenShift over Kubernetes, or Tanzu is making things easier for me rather than using the basic Kubernetes?
Tanzu, not anymore. That's old news. But okay. So think of Kubernetes is pretty much useless by itself, right? So think of Kubernetes being equivalent to Linux kernel, right? How many people use Linux kernel directly, right? How many people take the kernel, the source code from GitHub, the kernel, compile it themselves and say, this is what I use? Very few, almost nobody. Enthusiasts maybe, right? So what do you do with Linux? You don't take the kernel, you don't take the source code. What you do is that you take a distribution. You have certain needs, and then depending on those needs, you pick Red Hat or CentOS or Ubuntu or whatever you're choosing, right? Kubernetes is this. What you're describing is equivalent to those distributions, right? Kubernetes alone is not enough. If you install Kubernetes alone, you don't even have networking. Nothing really works, right? So those examples are examples of platforms or vendors that assembled in a way distribution of Kubernetes, right? And it's up to you to pick which one you want to choose, right? Very often people don't pick; they just go with whatever somebody sells them. But that would be a separate conversation, right? But yes, of course, you should pick a distribution of Kubernetes. And even when you pick a distribution of Kubernetes, more often than not, you're still not done. That would be kind of phase 2. You still need to, in some cases, not all, to make it useful, you need to install additional things like Argo CD that you mentioned before.
Okay. Yeah, so to add on to that, so Kubernetes, apart from having distributions like OpenShift, They are also adopted widely by public cloud providers. Like, for example, Google has Google Cloud Engine, AWS has EKS, Amazon has AKS, and all that. Um, so do you think they are bridging that, giving the edge given by these distributions? These cloud providers are doing it to an extent, or do you see there is still a lot of strides that can be done?
Done in what sense?
Like, for example, these are some capabilities that some of the distributions like OpenShift has already been able to pull off over Kubernetes, but these public cloud providers still have these capabilities to catch up to those kinds of.
I mean, I'm not sure how much they have to catch up from distributions like Red Hat, OpenShift, or it's the other way around. That would be a longer discussion. But yeah, right. So let's put it this way, right? Once you pick a distribution, and you need to make a choice whether you want to manage it yourself or you want somebody else to manage it fully or partially for you, right? A partial managed Kubernetes, that would be those that you mentioned, GKE, EKS, AKS, right? So that's basically them saying, okay, you know what? Part of the pain that you will have to manage it yourself, we are going to manage it, right? So it's in a way, think of it as layer above the distribution. They also have their own distributions. You can pick some add-ons depending on which one you choose, and then you're saying, hey, you do it for me. You manage some, not all of the issues. Now, there is a third option, or second, or fourth, or whichever it is, that say, you know what, I'm going to take full control, not full control, but management of that cluster fully. Everything. And that would be a good example of that would be Azure Container Apps, right? In case of Azure Container Apps, you don't even see Kubernetes. There is no Kubernetes for you. There is a Kubernetes behind the scenes, but basically Azure has combined a bunch of things and said, okay, you just tell me the image of your application and I'll do the rest. It's my problem, whereas that's running and stuff, and so on and so forth. So basically with Container Apps, and I'm using that as one example, the approach would be very similar to what we did years ago with Heroku, right? Kind of full platform that gives you everything no platform ever gives you everything you need, but everything you need for specific use cases. And you just have it easy. Here's my code, run it. Don't ask me any more questions.
Perfect. Yeah, it makes sense. Now that you talk about all these managing the infrastructure, managing the capabilities or the hosting of the applications, one of the key challenges that I find is it is all well and good that I want to distribute or convert my application into microservice and run it using Kubernetes. But managing costs sometimes also comes into picture. So we assume it is cost effective, but sometimes it might overshoot also. So what is the biggest challenge organizations face when deploying Kubernetes? Is cost a factor?
The biggest challenge is not Kubernetes or infrastructure. The biggest challenge are your applications. More often than not, when I see the costs, they're related to two things. One is the obvious stuff, like, hey, you don't know how much memory and CPU this application needs, right? Nobody does. But that's the least of the problems, right? Because you can find that out relatively easily. You can just run it for a month and then take a look at Prometheus or whatever you're using for observability, Zoho, right? And find out how much memory and CPU you really need. The bigger problem really, and the problem that very few companies want to deal with, is that your application is horrible. Right? Your application is the bottleneck. Right? Your application doesn't scale horizontally. So how do you want to scale the cost? You need to put resources to the maximum, even though most of the time you don't need it. Why? Because it doesn't scale, right? It doesn't keep the state outside. Basically, a significant number of our applications in general, are not what we would call, like 15 years ago with the mergers, going back to Heroku, what they coined the term 12-factor apps, right? Your applications are a bottleneck. Now, everybody focuses on easy stuff. Easy stuff is, oh, I need a bigger VM, or I need a smaller VM, or I need more memory or less memory. That's easy. Anybody can do that.
Infrastructure
But
cost is the biggest target. So they are the ones
yeah,
that are targeted the first.
yeah. So it's you. The problem is you more than anything else.
Yeah. Yeah, so that makes sense. But again, so you were explaining about Kubernetes architecture, all the different capabilities, all the different functionalities that it brings to the table. So, considering such a complex platform, what do you see as some of the biggest visibility gaps or big visibility challenges that is put in front of an administrator?
Okay, so administrator, not the developer.
No, we'll come to the developer later, but the administrator who manages the Kubernetes first. So, what is his biggest challenge?
The challenges start piling up when you run at scale. And that's because most of observability tools are doing the same thing and they're doing it wrongly. And that same thing is that I go to Kubernetes API, I get the data I need, and I do something with the data. I show you the data, I create alerts, and so on and so forth. Now, that's fine if you have one cluster. The moment you start having many clusters, that simply does not work. And it does not work because you cannot query properly etcd. Etcd is slow, and so on and so forth, right? Where probably the biggest improvement, and we can see solutions emerging in that space, is to begin with synchronizing all etcds from different Kubernetes clusters into one central database. And when I say, just not to make clear that people don't get confused, I'm not talking about synchronization of your logs of your application and things like that, or metrics. I'm talking about synchronization of etcd itself, which is, think of it as Kubernetes database. That's where all the that's where events are, that's where statuses are, that's where your resources are, and so on and so forth, right? Centralizing it somewhere in a type of storage that is not key value storage like etcd is, right? Which works okayish, not great, but okayish for a single cluster. Yeah, so and solutions are emerging, and there are already like 3, 4, 5 of them that actually will allow you to synchronize everything in a central database. Again, when I say everything, I mean etcd, not your logs and stuff like that. And from that moment on, something wonderful happens. And that wonderful is that you can treat all those clusters as a single entity, right? Most other solutions that I've seen is kind of, hey, this is the list of your clusters, right? And choose one of them, and you choose one of them, and then you see something happening, whatever, dashboard stuff. I don't want to do that, right? I want to treat all those clusters as one single big entity and start doing some exploration, some queries like, hey, give me all the pods that are misbehaving, right? And don't ask me where they are. I don't know where they are. They're in one of the many clusters I have. So moving away from etcd would be probably the biggest challenge in general that we have as industry, right?
Yeah, that makes sense. And considering you're an expert in in DevOps, Kubernetes in specific, you must have been there must have been a lot of organizations or individuals who must have come to you saying that we have a Kubernetes deployment. I'd like you to take a look at how we have deployed it, give us your feedback and all that stuff. So, so when you quickly analyze their deployment, what are some of the key signals that you see as a mature Kubernetes deployment? Okay, so they have utilized all their core functionalities properly. They are not just a basic. The deployment is not very basic, where they're just getting started with the various functions provided by Kubernetes. So when you look at it as an expert, what are some of the key components that you see in order to identify whether they have matured in utilizing Kubernetes or whether they are still in the starting phase?
If they're mature, they're not using deployments directly. If they're mature, they're creating their own CRDs and they're creating their own controllers And those controllers are managing pods, replicas as deployments and services and ingresses and what's not, right? So mature, kind of at the top of the pile. Those are people who are extending Kubernetes. They're not waiting for, hey, oh, I need the deployment and I need service. They're creating their own services, right? And they're exposing those services to the developers and basically acting as service providers within a company and saying, hey, what do you need? You need an application. Cool. Here is a CRD for an application. What do you need else? You need a database. Cool. Here is a CRD and a controller for a database and so on and so forth, right? So that's really mature. That's the top that we have right now. Now, if you say, what is the mature at the lower level, then yeah, the kind of before you discover the power of Kubernetes itself and the extensibility of Kubernetes, then I would still say that at that level, I think that maturity is shown through policies, right? So you don't try to force people to do this and that and use your health chart that you created and so on and so forth. You create policies that are guiding people towards the solution, right? And that's the key. How can I either want to give you a service, those would be the CRDs, or I'm teaching you how to do stuff. And the best way to teach somebody is to create policies. And then when you try to do something in your Kubernetes cluster, let's say that we say, hey, you must have memory and CPU requests set, and you have memory limits set, but you should never set limits for CPU because that's just silly, right? You create a policy, right? And when I see heavy usage of proper, very often they're wrong, but proper usage of policies like Kubernetes since maybe a year ago, half a year ago, has its own policy engine, which is Kubernetes Validating Admission Policy. So policies are really one of those signs, right?
Okay.
And if you go even lower, you can say, hey, let's even not talk about Kubernetes. Let me see your container image. And then if I see something like Ubuntu or CentOS or even Alpine as the base image, you still don't know what you're doing. You still don't know what you're doing.
Yeah.
Right? So it
you're
depends on the
better
level
off just using a
in.
simple Docker over actually utilizing. Yeah.
Say again?
So you're better off using a simple Docker as opposed to coming into using Kubernetes.
No. I'm not. That's not what I'm saying. I'm saying that the base image of your container images is one of the easiest signs how to see whether somebody understands what's going on. Like, the first instruction in any Docker file would be from, and then if I see people using from Ubuntu or from CentOS or from Alpine, you don't know what you're doing, right? We're not even talking about Kubernetes. Still, kind of like we're talking. How can you package your application in a container image with absolute bare minimum so that it is performant, it is secure, and so on and so forth, right?
Yeah, okay, that makes absolute sense. Okay, so considering we discussed about visibility as to what exactly is happening in your Kubernetes deployment. So I'd like to quickly switch to the role of observability or visibility of in your Kubernetes environment. So Kubernetes is obviously gives you an ephemeral environment. So that means it constantly spins up and down, and it also creates new pods, removes pods, so which is one of the most basic functions of what Kubernetes does, and that you need to be aware of. But considering all that capabilities of Kubernetes, the traditional monitoring, that is having a simple script that checks the status of your application or platform, might not work. So when you want to do anomaly detection or probably do some forecasting and all that, the various functions to make sure your Kubernetes is working fine. So considering the transient nature of these pods, so how are we supposed to approach it? So an organization transitioning from having an a traditional application architecture to a Kubernetes-based deployment. So how would they approach this? So obviously they need to make a huge transition in the whole approach of how they want to view the performance per se. So how would you say they should approach it? What would be the first few steps?
Oh, first, I need a couple of follow-up questions. You said anomaly detection and forecast. They are very, very different things.
Yeah,
Which one?
true.
Choose one.
Anomaly detection. Let's go with anomaly detection.
Cool. And the second question is, are we talking about SRE or something like that, or we're talking about developer?
Let's start with the SRE first. So the application developer will probably focus on them completely as we go.
So basically, if we're talking about anomaly detection, we're talking about on a level of the system, probably for some ops person, right? We're talking about very granular data. We're talking about ingesting as much as possible because you don't know what will happen in advance. And we are talking about relatively low retention, right? I couldn't care less about what happened yesterday, right? Because I'm not solving the problem of yesterday. I'm in that scenario. I'm solving the problem happening right now, right? Maybe it started few hours ago. It didn't start yesterday because if it started yesterday, then I should have seen it earlier than 24 hours later, right? And we have essentially three types of data that we're talking about, right? Very, very, very different data. We are talking about metrics, we are talking about logs, and we are talking about traces that serve very, very different purpose. Now, all of those three, essentially only metrics will give you the information that there is something wrong, right? You don't go through logs to find, you don't read every line of log to find out whether something is wrong. You have metrics, you have some thresholds, you have some alerts that are set, and now if the memory of this thing goes over 95% of what is allocated to that something, or if the pod restarted more than 3 times, kind of, it's okay to restart, but if it restarts continuously over time, and so on and so forth, right? And you get the notification. You were having dinner, you were doing something fun, you receive notification, and then you start digging into data, right? And that's where metrics and logs and traces come in, right? Metrics will give you typically the information to narrow down. Most of the time, it will not give you the information what's wrong. It will tell you, you see over there, that part of it, that's probably where you should look, kind of like. And then you will find out through traces if it's something directly related to user experience, or you will find with logs still if it's related to user experience, or if it's related to something specific, either to the system, and in which case logs in case of Kubernetes are events, or something related to the application, right? But then it's like gold digging, right? It's like being in a mine. You just start digging. Basically, you need to learn the language of the query of whichever engine you're using. And then you finally find out, and you solve it, and you're done. It sounds easy. It's never easy.
Yeah, I definitely understand. So that is one of the primary problems that we are trying to solve. So if we are to give someone a solution, so we need to be able to guide where they need to dig. So I understand how difficult it would be to know where to dig exactly. So yeah, that definitely makes sense. But when it comes to logs in specific, you obviously considering the volume of transactions and processes that are happening in the backend. So obviously the volume would be very high. So
very high for a very short period of time.
Exactly. So
Yes.
have you had difficulties with managing logs? Have you actually do you generally would recommend someone to use some tools, or do you have some hacks that they can probably use that can help them with especially the log tracking of it? especially going through the huge volume of events?
Yeah, I mean, there are a bunch of tools. Basically, they all do the same thing, and that thing is that you're collecting logs from everywhere, both from Kubernetes itself and from your application. You're storing it in a database, and you have some kind of user interface through which you can query those logs, right? And the language to query depends on the engine that the one is using. It's basically, there are many things that we're still trying to figure out, but that's not one of them. Kind of, it's a pattern that actually existed long before Kubernetes even. Ship everything to a central location and then query it.
Okay, so since you mentioned just a couple of minutes ago that metrics are one of the first items that you would look into to know if there is an error or some issues in the Kubernetes environment or not. So, considering you are building a dashboard with some of the key matrices for your Kubernetes environment. So, from your opinion, what would be some of the key matrices or some of the key pointers that you would look at or would want to look in a dashboard as an administrator, so that you always know what is happening in your environment?
Let me start that you should focus on alerts rather than dashboards, because it's more interesting to watch Netflix than to watch dashboards. And to be alerted when something is potentially going wrong. But once you find out that there is something potentially, wrong, really the key metrics are not that different in Kubernetes than long before Kubernetes. That's memory consumption, that's CPU consumption, that's disk usage, networking, and things like that. Basically, the story haven't changed much. What changed really with Kubernetes is that the way how we can retrieve those logs is much easier than it was before. But still, sorry, not logs, but metrics. But still, they're the same, right? They're based on physical capabilities. Two things actually: physical capabilities of your system and whether you're stretching those capabilities, and the unexpected behavior for your application, which hopefully, if you did everything right, boils down to the crashes and the restarts of your application.
Okay. So while discussing about observability, you did mention about three things: metrics, logs, and traces. So for traces, the traditional method of fetching traces is by deploying agents that could sniff or track the different transactions happening in your applications, and getting the stack trace or the trace of what exactly happened during that transaction. So the traditional method of deploying those agents is having a site container or a sidecar container in your deployment. So, and there I have considering I have helped in deploying these monitoring capabilities in various organizations. I've also seen some resistance in having a sidecar containers. So what is your opinion on having them? Would that be the ideal approach, or moving to some newer technologies like eBPF, where they get the data from the kernel, would be a much better approach?
Yeah, eBPF is definitely a better approach. I see sidecar containers more as a workaround until we figure it out how to do it better. They pose quite a few problems with your application. The order in which they're starting or not starting, they can crash. They're simply sidecar containers are the cause of too many issues that are okay if you don't have better, but we have better, but that better is eBPF, which not only that it reduces the number of issues that you will have with the agent itself, but also gives you much more granular data and much more information than you would normally have, right? And on top of that, sidecar containers are also heavy, right? You can say, oh, it's only 100 kilobytes. That's not much. But when you multiply that with 10,000 processes running in your cluster, then actually it can be quite heavy. So yeah, eBPF, that's the way to go.
Yeah, but we are still trying to dig into eBPF, probably get ourselves involved in some of the capabilities of eBPF per se. But one of the key drawbacks that we find with eBPF as of this moment is You can find out all the different traces, but the trace details don't go to the applications component level. So from a developer's perspective, you might not get the component level trace information. So would that be a drawback on a very highly development dependent deployment?
So basically, eBPF by itself will not what eBPF will not give you. That's the trace ID, right? Because yes, I can monitor the traffic between points A and B and C and C and D, right? But if that's all I'm doing, is that I know what is happening between those endpoints, but I don't have the picture of, okay, so what happened really? Kind of the request entered the cluster, and then it was processed by one application, and then that application forwarded it request to two other applications, and so on and so forth, right? You need to get with, and it doesn't matter whether it's Sidecar or eBPF alone, you will not get that picture, right? You will get only the separate pictures of each part of the journey of that request. To get a full, complete picture, you need to inject an ID, right? So whenever the request enters, it gets some ID assigned, whatever the ID is, and then it's responsibility of each process in the system to, when it enters the process captures that ID, and then when it sends a follow-up request somewhere else, it attaches that same ID to that request. And then you collect all those and say, okay, so what are all the requests and the timestamps of all the requests with the ID 1, 2, 3, 4, right? And you assemble that as a picture, and then you can paint the picture and say, oh, okay, so this thing that was misbehaving, it went here and there, and so on and so forth. Basically, you're assigning a tracker, right, to requests, so that you can combine different requests into one big request that is floating around, or not only one, but multiple requests floating around the system. So the ability to inject that ID or to read the existing ID and inject it in the follow-up request is what you need to assemble that picture.
Yeah. But another core usage of traces is to find out code level shortcomings as well. Like, for example, if there are exceptions, or if there are any ways the code could be optimized for the application's performance to improve. So would this also help with that, with the improving?
So each of those traces has ID that I mentioned before, but it has timestamp and it has additional information, like let's say duration, right? And now, if one single big trajectory of requests consists of 57, it can consist of one request or 57 different requests, and each of them can be split into spans, right, or tiny segments. And how many you will have depends really on you. One easy hack you can do is to say, I'm going to instrument my application as a whole, right? So whatever something enters into my application, then something exits, and I can track it. And then you get a very high level overview of what's going on. Or inside of your application, you can go a step further and say, you know what, I'm going to insert a span in this specific function or this specific part of the function, right? So the deeper you go within your application, because outside application that you can do automatically, no problem at all. But within application, it really depends on you. It's in a way similar to logs, right? You can say, hey, I'm just using logs of the framework I'm using in application, or you can start printing logs yourself. It's just the traces are, think of them almost like, or spans within traces as injecting additional information in parts of those requests. And then you can find out, okay, so it took 1 second for my application to process this request. But within that 1 second, we spent 90% of the time in this function, and the other 5 functions that were executed took 20% of the time, right? But to do that, you need to instrument it yourself.
Good. Yeah, that absolutely makes sense. So now that we have discussed this factor, so I'm going to quickly jump back to one of the topics that we touched upon in um, at the beginning of our discussion. So when I was talking about public cloud providers, one of the major concerns that they have with going with the public cloud providers is the cost factor of it. So Amazon or Azure or whoever that might be. So when you are initially deploying not just Kubernetes but using these cloud providers in general, would seem like a very cost-effective decision, but as you scale, sometimes it might not be the right decision. So I'm not saying it is never a right decision, but sometimes it might not be. So similarly, deploying Kubernetes will also obviously involve cost. Like we discussed earlier, it obviously involves infrastructure cost, and and another cost that nobody really or not a lot of people realize is the error cost. That is the cost that you incur because of having some lack of service or delayed service and all that. So,
And
uh,
human cost.
ra- hmm?
And
Sorry?
human cost.
Exactly, human cost. So, at least from a technology perspective, so deploying Kubernetes and understanding what costs you're incurring by deploying that and maintaining that deployment. So, how important do you think that is? What are some of the um, is it always tool dependent to know what cost you're incurring, or is there some techniques or hacks that we can do to actually know what cost we are incurring?
Yeah, I mean, there are a bunch of tools, starting with open course, that is open source, and then and it's in CNCF, I believe, to commercial options, many of them, um, that will give you information, right? How much something costs.
Mm-hmm.
Uh, Now, I believe that I don't like the approach of all those tools being focused on cost, because I don't think that it's about cost.
Mm-hmm.
I think it's about optimization,
Mm-hmm.
right? How can I optimize my stuff to use exactly what I need and not more and not less, right?
Mm-hmm.
How can my application have just enough memory and CPU and not more, right? How can my application scale up and down depending on the changes to the traffic? How can my cluster scale up and down in the number of nodes and so on and so forth, right? And once you figure that out, once you figure out how to do the things right, then not much is left in terms of optimization. After that, you can start thinking, oh, okay, should I use cheap servers or expensive servers and stuff like that, right? Or spot instances. But the major one really uh, is is about not necessarily about cost, but about you doing things wrongly, right? You just kind of, oh, my application is 57 gigabytes of RAM, kind of like, come on. It doesn't. You're just putting it because you don't know how much you need, right?
Mm-hmm.
You're putting a random number. And very often the whole cost issue comes from um, I mean, first of all, there is a real cost that we can talk about if you've highly optimized whether AWS is too expensive or no, right?
Mm-hmm.
But for many companies, it's not about if you're too optimized, you're not optimized. And very often, you're not optimized because you're coming from self-managed, from on-prem, and
Mm-hmm.
you're used to very different type of operations, right? Oh, this is my server, right? Kind of, it's mine. It's on my application. Doesn't matter whether I need it or no. It's mine, and it's my darling, and I'll treat it like a girlfriend or a cat or a dog or whatever you want.
Mm-hmm.
Well, cloud is highly dynamic, right? Now you could have dynamic self-managed on-prem setup as well, but nobody did, right?
Mm-hmm.
So the first step is understanding that this is not the same. This is very different. This is completely dynamic. Then it's understanding the technology you're really using so that you don't do silly things. And only after that, kind of the final touch would be, okay, so is it okay if I use spot instances or no? Maybe it's okay for 50% of my replicas, and so on and so forth, right? And more often than not, that goes back to what I said very early on in this session. It's not only about moving your stuff to cloud, it's about re-architecturing your stuff to work well in cloud, right? You will often find out that actually, again, it's your application that is the biggest cause of the misery that you're experiencing. And one more thing also that I feel it's very important is that AWS, Google, and Microsoft, and Alibaba, or whatever, the big guys, they're not the only options one has, right? There is a bunch of other clouds or hyperscalers that are offering you services for like half or 1/3 or 1/10 of a price, right? What you need to figure out is, what do you need? If you just need VMs, you don't need AWS, or you don't need Google, and you don't need Azure for VMs, right? If you just need Kubernetes and you don't need it to be highly available, meaning that it doesn't have to be split into multiple zones of the same region, if you don't need it, you can go to, I don't want to name specific organizations, but there's a bunch of them that will give you the service that you need for infinitely cheaper, right? What makes AWS and Google and Azure special is the volume, is the kind of like they have more data centers than anybody else. They have more services than anybody else. They have more skilled people involved than anybody else, and so on and so forth, right? And that's absolutely amazing. But you're paying premium, right? So it's like driving a car, right? Kind of, you can buy a Lamborghini and you can buy Kia, right? And both of them might be just the right choice or the bad choice for you, right? And I feel that people are often forgetting that AWS is not the only cloud provider, and Google and Azure in the world.
Yeah, it absolutely makes sense. But another cost that generally a lot of organizations either overestimate or completely avoid is the cost of observability. So whether they want to invest in a tool for getting the visibility that they want to, or whether they choose to simply do it manually or have a very basic open source solution. So there are all, just like you mentioned about AWS, Azure, and all the different hyperscalers who are not the known names, but still giving you the right fit for your requirement. So the same applies to observability as well. So is there so would you have a similar definition or answer for observability also, or do you think there is a balance between mixing to get the right solution for your environment?
I think the story is very similar, right? Just as with, let's say, clusters, you can first choice is, do you want to self-manage or you want it as a service, right? I would make a small correction to what you said. You said open source, very basic. I don't think that open source is basic at all. The advantage of commercials is not that they are less basic, that they're more advanced. Open source is very, very capable and very, very advanced. You might often not choose to go open source, not because you're getting something better, sometimes you do, but because you don't want the burden of managing it yourself, right? Just as I don't want the burden of managing. So, for example, I use Kubernetes as a service almost exclusively, 100% of the time, right? And that's not because I cannot do it myself by using kubeadm to install Kubernetes. I can do it. I just don't want to do it. And AWS or Linode or whomever else I'm using will give me a better service, and more importantly, the better service will give me Kubernetes as a service, so that I can dedicate my time on what really matters, right? Kind of like, I'm not interested in running Kubernetes, I'm interested in my applications. And the same thing goes for observability, right? You can assemble it yourself. Depending on how experienced you are, it will take you a few hours or few days or few months, maybe even a year to assemble observability from open source, right? And then on top of that, you will be paying the price of managing that something, because it's not that you're finished after you install it.
Correct.
Or you can go with the commercial solutions, and that's often better because you should focus on your business, right? That should be your main focus. Now, within commercial options, you have different ones. You have those that cost less, you have those that cost more, and so on and so forth, right? So you need to make a choice.
Yeah, it definitely is a very valuable feedback from you. So, so that especially the last portion that you talked about is one of the key functionalities or the key topics that we have to discuss with some of the organizations that we end up doing business with, or discussing all the different industry happenings and all that. So now let's quickly jump to we were earlier when we were discussing, I was telling you, okay, let's talk about SRVs right now. Let's go to the developers later. So now let me quickly jump to the developers part of it. So from a developer's perspective, so Kubernetes is one of the key components of their DevOps cycle.
It shouldn't be.
Yeah,
it should not be.
I know. So how exactly do you think developers are balancing the? I mean, Kubernetes has been in the market, or it has been utilized for quite a few years now. But have you seen developers finding it difficult to adapting to their applications being deployed on a Kubernetes environment over the previous simple VM or server-based deployments?
Okay, so there are quite a few things to unpack there. First, let me start with some outrageous thing, and that's a statement, and that's that Kubernetes is actually the easiest way to accomplish certain things. It's not harder; it's easiest, right? Like how to make your application highly available, right? I would challenge anybody to tell me easier way to do it than with Kubernetes. Now, the question is whether you need it, right? And you can easily say, actually, I don't need the capabilities that Kubernetes gives me. Yeah, I'm fine with running a single replica of my application on a single node. And that's all I need. Cool. And then you don't need Kubernetes, right? But once you start needing those capabilities, like security, like SSL between MTLS between requests, and so on and so forth, then Kubernetes comes into play, right? Because it's a standard in a way. So the first question is whether you need it or not. But once you do, if in cases when you do need it, the thing that is missing in most cases is that from the developer perspective, Kubernetes should not exist. Right? When I say it should not exist, I don't mean it should literally not exist. I mean it should not be visible. Just as, for example, if you use hyperscaler like AWS, right? And you create a VM, EC2 instance, you don't see the hyperscaler, right? That's one of the big advantages that AWS gives us. In the past, I would need to go VMware, this and that, and Twinkle and do a bunch of things. No, I just kind of, that's in a background. I just ask for VM, and VM somehow automatically happens. The same thing is the direction where we're going with Kubernetes. And that's that it's just it's there, it's happening, but you as developer, you should and going back to my previous conversation, CRD, that is called application, you define it by specifying 1, 2, 3, 5, 10, whatever fields, depending on what you really need, and off you go, and then things are happening. Now, that's the easy part. That's the easiest part. The harder part is what happens after that. Like, for example, how do you know whether your application is not working, right? Now, you cannot say, oh, you know that your application is not working when you check the pods and you check the containers and you check the services and you check the 57 different things, right? That's the wrong answer. I'm going back to the Heroku model before, or Azure Container Apps. That's probably the missing piece today. We need to figure out how do we provide feedback back to developers at the right level of abstraction. What are the things that matter to them, to the abstraction that they're using, how to propagate those things back up the chain from the child resources back to the parent and visualize it somehow. And that's a problem that nobody seriously solved yet, but it's happening. We're going to solve it.
Okay.
When I say we, I mean industry as a general.
Yeah, makes sense. So I know this topic, this discussion that we are having is primarily focused on Kubernetes, but since you said a developer should forget that Kubernetes should exist, so in an environment which is constantly focusing on CI/CD, that is constant integrations and deployments, what are some of the key how would you say it? What are some of the key factors or best practices that one should follow in their CD based environment? So obviously, as we know from this hour's time of discussion, Kubernetes is going to be a key factor, but the developer is going to forget that it exists. What are some of the other key practices in having a CD environment, and does observability have a part to play in that? What kind of a role does it have?
Yeah, so CD is partly the same and partly very different. Basically, the emergence of GitOps introduced. So CD in the past, and still today to some extent, is very monolithic and very sequential. You do this, and then you do this, and then you do this, and then you do that, right? What Kubernetes in general and GitOps specifically changed is that they made it eventually consistent and event-based, right? So you're not control the flow. All of a sudden, different things are happening as reactions to different events, and they are all somehow at the end fulfilling certain SDLC, right? So you might be triggering, let's say, a pipeline, whichever pipeline you're using, when you push something to Git, and then you will have a couple of things will be executed, and then that's the end of it. And then some other things will be happening outside as reactions to those events. So the key change really is that we are moving towards event-based flows, which are very similar to microservices we discussed earlier, right? Just as before we had one big application that is doing something, now we have microservices, and they're all doing different things and reacting to different events. And we still need to figure out, I don't think we did yet, how can we connect all those events? Just as with microservices, we're collecting them to traces. In case of CI/CD, I don't think that we figured it out yet, and that's one of the big challenges we have. And there was another part of the question that I now forgot that you asked. I forget things.
The role of observability, or the importance of observability into CD.
Yeah, so there are many. When people talk about observability, they usually think about dashboards and alerts, which are definitely part of observability. But there are many things that are also observability and happening without much human intervention, really. And observability is very often today used by different processes. So a good example would be your deployment, right? So you can just deploy your new release, and you say, that's what I did. Right? Or you can do something like canary deployments and say, how about that new release, I start serving to 5% of my users. And then I have a process over there that will use the observability, basically metrics, let's say, to see what's happening. How is those 5% reacting to it, right? Oh, are they happy with it? Do we have the same or lower rate of errors? Is the latency okay? And all the other things that we are normally observing as humans. And then it can make a decision. Okay, so let me increase that release reach from 5% to 15%, right? And then continue monitoring the situation gradually over time, which could be 5 minutes or can be maybe 5 days even. I have the release fully rolled out, right? And we can observe similar thing in other parts of SDLC, mostly automated these days. But canary releases would be one of many examples of how you can actually use observability in, let's say, less conventional way, right?
Okay. So we are almost coming to the end of it. So before we end it, I have one quick topic that I would like to discuss about. So the current trend in the technology market is obviously AI. So everyone is talking about AI, AI this, AI that, and all that. So in enhancing someone's Kubernetes management or Kubernetes visibility, what are some of the AI capabilities that are already in, or some of the capabilities that you think are not yet there but would be much more efficient if we use AI? So, what are some of your inputs in that?
So there are good and bad things right now, or good things and things that are missing.
Mm-hmm.
The good thing is that we have LLMs that basically contain the knowledge of the whole internet, right? Kind of, there is no human on this planet that actually has even fraction of the information that LLMs have. That's absolutely great. That's part. Think of it like being Wikipedia in your head, memorized, right?
Mm-hmm.
Absolutely amazing. AI is so much better than we are. What is happening right now, and that's already the old story, is that we're getting capable agents right now being able to, because just knowing stuff is not enough. You need to be able to go and look at the system, find some information, make a decision what to do with that information, and then find some other information, make some other decision, and so on. The same thing is what we're doing, right? If I'm a human and I see some problem in a dashboard or wherever, it's not that I saw the problem and that's it, right? I will go somewhere else, check something else, perform some operations, and so on and so forth, right? And ultimately get to the point. Agents are getting there. They're not there yet, but they're getting to have almost the same capability or better capability than we are at performing operations and gathering data that they need to make the final decision, right? And that's a good part of the story. So agents, amazing. LLMs, absolutely amazing. Think of it like being knowledge is there and the ability to perform actions is almost there. What is missing is memory, right? So let's say if I go now to and see, oh, look at this, my Jenkins is out of memory and it crashed and it was restarted by Kubernetes, right? If you ask AI what to look at it, AI will tell, oh, it's out of memory, you need to do something, kind of, this is wrong, this is an error, and so on and so forth, right? On the other, and it will do that because it does not know what happened yesterday and it has no memory. It always starts from scratch. While you as a human, you have experience, right? Oh no, that's happening every week to us. Kind of like we ignore that. Kind of like there is nothing we can do, right? I mean, this is a silly example, but simply, I feel that what is missing next for AIs is to be capable of learning. And I don't mean learning like scraping internet. I mean learning. Okay, so I did this yesterday. I don't need to start over today. I can continue based on that knowledge. We can do that. AIs cannot do that yet. They have relatively small context, right? They know everything, but the context is very, very small. infinitely smaller than the context we have in our heads when we approach a problem. So I expect that the next phase of AI will be some way to maintain the context of everything that AIs did and discovered so far, so that they don't always start from scratch. Without it, there is no learning. And without learning, basically, AIs most of the time make mistakes. And that's okay, because humans make mistakes as well. But if they make mistakes and give you wrong answers, and especially since they don't have the context from before, that means that LLMs or AIs are useful much more to experienced engineers than to juniors. And usually it's the other way around. Junior, less experienced people are more interested in AI, which I think it's wrong at this stage. Like only this morning, I was writing some code, and I used Cursor actually to help me out with that. And I was actually working on a front end and a back end. And with the front end TypeScript, I typed what I want. It did it in 10 seconds, and I'm done, and it was working and great. And then I turned my eyes to a backend. I asked for, told it to do what it needed to do, and then I noticed that oh no, actually it created a struct, and then it moved struct to variables, then it loaded variables to another struct. It was doing some things that I would never do in that code myself. So I had to spend like an hour, and eventually ended up spending more time with AI than if I did it myself from scratch. Now, the major difference in those two stories, that I did front end in 10 seconds and I spent hours with the backend, which is written in Go, is that I don't really know how to write TypeScript code. So I accepted what it gave me without really judging it, right? But when it came to Go, which is the language that I use most of the time now, I immediately noticed the differences, right? So it's very dangerous to use it right now if you're not experienced, right? If you're experienced, you will find out when it's doing something completely wrong and when it's right, and you will be able to make those decisions.
Okay. Yeah, it's good to know that it is maturing, but it still needs some more context.
This is the very beginning. We are still, it's hype, it's interesting, and so on and so forth, but we're just at the beginning of this story. This is not the AI that we will have a year from now, or 2 or 5 years from now. We're just starting.
Yeah. All right. So just one final question. So as an expert, what would you probably give as an advice? I wouldn't say advice, but some of your observations on how organizations can stay ahead in observing their Kubernetes and ensuring they are able to have long-term success with their deployments. So what are some key findings or key observations?
I mean, I wouldn't say that Kubernetes is being proficient with Kubernetes. That's not staying ahead. That's already that's not the future. That's the present. We've been having it for 10 years now, 11 almost. We had containers for like 15 years now. And Kubernetes is mature and used by a lot of very serious organizations for many years now. So this is not a novelty anymore. Oh, the new thing. This is not a new thing, just to be clear, right? But how can they stay ahead? I think that the biggest problem that many individuals or companies are facing is that they're very often jumping into something without understanding the fundamentals behind that something, right? Like, for example, you might start using Kubernetes without understanding how Linux works, and you're going to fail, right? Or you're going to start using Kubernetes without understanding how to write code, and that will fail as well, because you will not be able to create those controllers and so on and so forth. So there is, think of Kubernetes being the top of the pile, the iceberg that you see, right? But there are so many things below that if you don't really understand, you might easily get lost. So my advice is always start from the bottom and try to find your way up there somehow.
Mhm. All right. So that was definitely insightful. So before we come to a conclusion, I'm quickly going to jump and introduce who we are and what we do. And then uh, once I'm done with that, it'll just take a couple of minutes. I'd like you to share any closing thoughts that you have, and then we should be done.
Go for it.
So we are ManageEngine, and ManageEngine is basically an enterprise solutions organization, which is a part of Zoho Corporation. So from an Kubernetes observability is concerned, we have a Kubernetes observability platform, which you can use for monitoring and observing your Kubernetes environment. So we have two different offerings. One is on-premise, and we also have a SaaS-based cloud solution. The on-premise solution is called ManageEngine Applications Manager, and the cloud one is called as ManageEngine Site 24/7. So our solutions help you to proactively monitor your Kubernetes environment. It gives you an unified monitoring with the full stack view, which includes the application performance monitoring via traces. It also helps you monitor your infrastructure, irrespective of whether it is a basic server, VMs, Kubernetes, and also we have cloud-based monitoring. We also have some custom dashboards, which gives you a holistic view of both the Kubernetes and the underlying infrastructure. And you can also create your own custom dashboards with personalized metrics that you find are key for your organization's optimal performance. We also have some AI-powered insights, which helps you get some smart alerts, anomaly detection based on patterns, and also root cause analysis. And we also give you some some insights on cost efficiency, and help you get high return on investment, reduce downtime, and also you can optimize your resource consumption. So just briefly introducing what solutions we are offering. Thank you once again. So Viktor, do you have any last words for us?
Ooh, last word sounds so final, like I'm going to die today.
No.
No, I'm kidding. No, nothing special, really. Just keep learning. That's all. Things are changing all the time. Whatever I said today, tomorrow I will change my opinion, right? Things change. Keep learning. You'll get there.
All right. So that's good to know. And thank you for your wonderful time. And once again, I'd like to thank Viktor for taking time off his very busy schedule and joining us for this wonderful insights and inputs on managing Kubernetes, observing Kubernetes, and also getting some values. Hopefully, this session was useful for you, and it would actually help you understand how and why you use Kubernetes, and you make a full use of its capabilities. Thank you everyone for joining us today, and hope you had a very insightful session, and you enjoyed our discussion with Viktor. So thank you, and you guys have a good day.
Cheers, everyone.
Cheers.